Let's take a look at sequences and series. Given the formula a sub n is equal to 2n for the natural numbers between 1 and 5 inclusive, we generate a sequence of 2, 4, 6, 8, and 10 simply by plugging in the natural numbers 1, 2, 3, 4, and 5 in for 2n. A series represents and takes the exact same numbers, but now represents that sequence as a sum of those values. So 2 plus 4 plus 6 plus 8 plus 10. Sometimes series can get really long, so instead of writing out the whole list of all of the values, we have an abbreviated form called summation notation. I'm going to preview that here. Summation notation has this E symbol, which is called sigma. It's a Greek letter, and it's used to represent the sum. And so this is then representing that same series by saying that I'm taking the sum from 1 to 5 of 2n. Now I will also ask you to give me the actual sum of the series. If I specify that I want the sum of the series, then I'm asking you to actually total up all of those values. So I'm asking you, what is 2 plus 4 plus 6 plus 8 plus 10? And you would tell me 30. In review, the sequence asks you just for the list of numbers, whereas the series asks you for the list of numbers with a sum. So it asks you to write that list separated by plus signs. The sum of the series is asking you just to take that list of numbers and give me the total. Let's take a further look into the summation notation. When introduced to that, I said that this symbol was a Greek letter. It is representing sum, but it's actually called sigma. You will very infrequently hear it called sigma. You'll simply read it as the sum of. It'll be the sum of some formula for values of n starting at the number on the bottom and ending at the number on the top. So you will read this as the sum of, in our case, 2n, for n between 1 and 5. Whatever variable is used, in this case n, is referred to as the index. So let's take an example. I want you to find the sum of this series given to you in sigma notation. Now this time my index is I. It's really important that you note in this notation, I is simply representing a variable. It's not representing the imaginary numbers. So I want to rewrite this or interpret this as a series. Well, I'm going to take 1, substitute into my formula 2 to the negative I, or 2 to the negative 1, plus, then 2 to the negative 2, all the way up to 2 to the negative 5. So I'm replacing I with the values 1 through 5. This gives me 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32, which equals 31 out of 32. The sum of the actual series is 31 32seconds, or 31 out of 32. The actual summation notation is what was given to us when the original problem was presented. So all of this that's being boxed here is the summation notation. The list that we generated with the plus signs was the series. And then the final answer, the 31 out of 32, is the sum of the series. That's our answer. Let's take a look at the calculator. We've already talked about how to input a sequence, so you'll see that I'm doing that here. Simply inputting my sequence by going to second stat, then to ops, clicking number 5, putting in my formula, then comma my variable, then my start value, then my end value. This generates my sequence, which I'm then going to change into fractions so I can check my work. I can arrow over just to make sure that it goes all the way to 1/30 seconds. When I want to find the series, I'm going to go through the same first steps, second stat, then over to math this time and down to sum, and I want the sum of that sequence. So I want the sum of all of those values. And so I'm going to take the sum of the answer and then change that into a fraction. Make sure that you can use your calculator to do that as well. In our next example, we're asked to write the series this time in summation notation. In order to do that, I notice first that I have alternating signs in between my terms. This tells me that I'm definitely going to have a -1 raised to the n plus 1 up top, specifically because my very first term is positive. And then in my denominator, I notice that it goes 1 through 6, so it's just representing the term, so I'm just going to divide by n. This then is my formula, so I'm going to put this into my summation notation. So I'm going to begin by writing out sigma, and I'm going to start with my index being n. It's going to start at the value of 1. I have 6 terms, so it's going to go up to 6. And then I'm going to write the sum of specifically the formula that I just found. -1 to the n plus 1 power divided by n. This entire thing then here represents my summation notation for the given series. Lastly, we're being asked to rewrite this series using a new index. So first I'm interpreting this series. It's x raised to the power of 2i plus 3. And so I'm inputting the values 1, 2, 3, and 4 to get x to the 5th plus x to the 7th plus x to the 9th plus x to the 11th. They're asking me to rewrite this using the summation notation, but this time with an index of j. So they want me, instead of starting at 1, they want me to start at 0. Well, I still want the exact same series. So I'm just trying to interpret it in a different way. This time I want to start at 0. So j equals 0, then j equals 1, then 2, and then ends at 3. So I know the value that goes at the top of my summation is 3. Well, I need to ask myself, how can I rewrite x to the 5th with an index or a value of 0? Well, I could easily do x to the 0 plus 5. But then what if I have 1? Can I represent it as x to the 1 plus 5? That won't give me 7, but 2 times 1 plus 5 will. So I'm going to test that out. Would 2 times 2 plus 5 give me 9? And it does. And it also works for the 4th term, 3 times 2 plus 5. So now I've developed my pattern. I see that it's x raised to the 2 times the j plus 5. So I've successfully rewritten my summation notation but now with a new index.